Namaskar. Welcome back to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. We are discussing the textbook for class 9 and we are doing a chapter by chapter analysis. And I hope that you remember our last interaction. We discussed chapter 8, that is motion. What did we understand? We discussed what is uniform motion, what is non-uniform motion, what is speed, what is velocity, what is distance, what is displacement. Rate of change of velocity is called acceleration. All these things were understood, and we also established certain facts like we can describe motion in graphical forms. We understood the distance time graph, velocity time graph, acceleration time graph, and we also discussed the equations of motion, though we did not focus on deriving them, but we just understood the equations of motion. Today let's move on and discuss chapter 9, which talks about force and loss of motion. This would be an easy interaction because we have already established many facets of these when we discussed different chapters from class 6, class 7 and class 8. We already know what is force and we have some ideas about loss of motion. So let's talk about chapter 9. But before all that, I hope that you have already enrolled for the Prelims 2 interview initiative, which has begun from 19th June. Only the orientation class is done. You still have an opportunity to join the most comprehensive and the integrated batch for UPSC civil services preparation. It has everything in it. For prelims, we have a prelims test series already in it. For mains, there is mains answer writing program. If you clear your preliminary examination, you would be called to StudyIQ's residential program. It would be like a Gurukul setup where rigorous answer writing practice would be conducted. There would also be mock interviews. There is already one-to-one mentorship, group mentorship. Everything is included in this complete package. It is at a very affordable price as well. For maximum discount, do use the code Rahul Live. If you have enrolled, I'll see you in the class. If not, do it now because it's now or never. Every time when you want to take a decision, you're always in a dilemma. Should I do it? Should I do not go for it? Is it tough? All these things would be cleared. All your doubts would be cleared as soon as you enroll for this, because a mentor would be assigned to you who would be helping you throughout your journey. Right. I'll see you in the class. All right. Today's discussion is about force and loss of motion. All right. Now, as I told you in our previous interaction itself, in this world, everything is in motion. In our body, blood is in motion. The entire universe is continuously expanding. Earth is revolving around the sun. So motion is something that has flummoxed many scientists, many people, many physicists, theorists, many philosophers as well. How do we define motion? How do we understand? What is the cause of this motion? Is force the cause of motion? So we have understood what is force as well. So we do understand for something to be in motion, there has to be some force acting on it, and that force need to be unbalanced, right? That is how something starts into motion. So we'll talk about forces, how motion starts, why a body will be in rest, and then we'll jump into the laws of motion given by Isaac Newton. Many physicists like Galileo Galilei, Isaac Newton, they have worked on this and they have given us some established rules and regulations. First things first, what is force? We have already established force is either a push or a pull. In our previous interactions, we have also discussed and categorized different kinds of forces. Contact force, right? Muscle force is a contact force. Friction force is a contact force. But there are many non-contact forces. Classic example being gravity, right? If I drop this pen is going to fall down on the ground. Why? Because a non-contact force is working on it, which is called as gravitational force. We have discussed other non-contact forces as well. For instance, the electrostatic force, the magnetic force, all these are non-contact forces. So a force can be a push or a pull. It can be a contact force, non-contact force. And in our day-to-day interaction, we use force for some sort of motion. For example, this kid is moving this trolley. You must have gone for shopping, and in shopping cart, if you go to Reliance Smart or More Shop or any other shop, you will get a trolley like this. You put things in it and then you push. Now, how is this trolley moving? This trolley is moving because this kid is applying force in this direction. That is why the trolley is moving. Similarly, if I have to take something out from my cupboard or my drawer, what do? I draw this out, the drawer is being pulled out, meaning I am applying some sort of force on it. Similarly, the kids here are playing hockey. Now, whenever you hit this ball, this ball starts in motion. If you do not hit it, the ball will be at rest. So the question is, why this ball is at rest and why this ball is in motion? Because when something is in motion, there is always a concept of unbalanced force. So we need to understand that if there is any body, there are different kinds of forces acting on it. And whenever these forces are balanced, then there is no change in the state of motion. If something is at rest, it will remain at rest. Now this picture, it classically explains what is the meaning of a balanced force. You can see here there are 3 people on this side and 3 people on this side, and they are pulling a rope, tug of war basically. And if the forces are balanced exactly in opposite direction, now in this side there is 300 Newton, this side there is 300 Newton, then the mean position of this rope, it is not going to change, meaning the rope would be rather stationary like this. The position would be exactly there. So whenever there is an object or a body on which equal forces in opposite direction are working and they are exactly balanced, that means there is no change in the object, or there is no change in the motion of that object. Clear? But if something starts in motion, or if the state of motion is changing, that means there are unbalanced forces which are acting on it. This is a classic example. There are 3 people on this side, that means they are employing a force of 300 Newton in this direction. But there is only one person this side who is applying a force of 100 Newton. Now what is going to happen? There is an unbalanced force here. What is the net unbalanced force? The net unbalanced force is 200 Newton due this side, meaning this person or this rope is now going to move towards this side with a force of 200 Newton. That means whenever a body or an object is set in motion, meaning the forces or under balanced forces, it was in rest, and as soon as these forces become unbalanced, it starts into motion. Again, classic example, whenever we try to push a box. See, we discussed about the frictional force. Now, these 2 people are employing a force on this particular cupboard or a box on this side, towards this side. Now, the friction force is acting. Whenever they are pushing it, the friction force is resisting the motion, meaning the amount of force that they have applied, the friction force is exactly balancing it, and the movement does not start. So what do? They try to push it more harder. Now, these 2 people are now using all the energy that they have and again employing force F1, but they are not able to cross the frictional force. The frictional force Fn is again equal to this. That means the body will still be at rest. So this body is at rest. This body is at rest. Now you do know friction force depends on the contact, meaning there is some sort of interlocking happening between this surface and the box. That's why there is friction force which is acting. But these 2 people, they gather more energy. They take a few breaths and decide that we are going to move this block. Now both of them, they employ a force F2. Now this F2 is much higher than the frictional force here. Whenever the force F2 is higher than frictional force, meaning now the box is going to go in this side. It is going to move in this side, meaning there is now unbalanced force acting on the box. That is why the force is towards this direction. The box is also going to move. Clear? So if there is a change in state of motion of an object, that means there are some unbalanced forces which are acting on them. That's the idea of force. And based on this knowledge of balanced and unbalanced forces, we need to understand Newton's laws of motion. When a body gets into motion, what are the characteristics of that? Isaac Newton has given 3 laws of motion. The first law states every body continues to be in state of rest or of motion in a uniform straight line unless and until it is compelled by an external force to act otherwise. If a body is in rest, I put an unbalanced force on it, it starts to move. If a body is in uniform motion in a straight line, I apply a force, it is going to stop. Right? That is the first law. The second law states the rate of change of momentum is directly proportional to the force that is applied, and the motion is in the direction of the force. The third law, my favorite, for every action there is equal and opposite reaction. So let's try to understand each law more thoroughly. As I told you, first law, it states that every body, every object, it tends to remain at rest, or it tends to remain in a uniform motion along a straight line unless some unbalanced force is acting on it. The best way to understand first law of motion is I simply keep this particular pen. I simply keep this particular pen on the table. I've kept it, I've left it. I come tomorrow, the pen is there. I come day after tomorrow, the pen is there. I come after a month, the pen is still there. Why? Because balanced forces are acting on it. The pen is undergoing balanced forces. It's basically its weight and the gravitational force are acting on it, and it is at rest. It will remain in rest till what time? Till I apply some force and pick it up, till I apply some force and move it to another direction or another position. So the tendency of a body, if a body is in motion, it tends to be in motion, or if a body is in rest, it also tends to be at rest. So first law of motion, it gives you two important features or two important characteristics. One is the idea of friction and another is the idea of inertia. Now let's try to understand both of these. Now when I talk about friction, Newton's first law, it basically lays the principle for friction, the idea of friction. Now what it says, every body continues to be at rest. Let's not talk about rest, but let's talk about uniform motion. Meaning, say I am a cricketer, I have hit a ball. I have hit a ball. Now the ball is in uniform motion. It is going in a straight line towards the boundary, but it does not reach the boundary. Why? Because there is some sort of an unbalanced force which is continuously acting on it, and that is called as friction force. Friction is a force which depends on the contacting surfaces, and friction is a force which always opposes the motion of that ball, right? So first law, it basically lays foundation to the frictional force. Frictional force is an unbalanced force that causes an object to stop, that causes or that brings an object to rest. That is the idea of friction. And the second important concept that Newton's first law gives is the idea of inertia. Idea of inertia, meaning if any body, it is at rest, it tends to remain in rest only. Because even if you try to apply some force, let me just explain through this. Now, I gave you this particular example. Newton's first law, it clearly satisfies here, right? This particular box or a cupboard, it is trying to remain at rest only. If they apply the force, the frictional force is balancing it, it is trying to remain at rest only. It will move only when the unbalanced force, it is more than the counteracting force, in this case frictional force. So every body tends to be at rest. If it is in motion, it tries to remain in motion. Now that concept or that entity is called as inertia. Inertia. Now you must have seen this example that if something is in motion, I suddenly try to obstruct it. What is going to happen here? Now this body has stopped, but the ball here, they are in motion along with this trolley. As soon as I stop it, the balls try to continue their motion. This is called as inertia, and this kind of inertia is called inertia of motion. But if something is in rest, for example, I have kept a small playing card here on which there is a coin, and if I flick that card, along with the card, you expect the coins also to move, but the coins do not move. Why? Because the coins were at rest. Even if some force is applied, they tend to remain at rest. They tend not to move along with the card, and they fall down in the glass. Similarly, you must have seen while playing carom, you must have seen during your childhood, you must have played carom, and through this striker, when you hit hard on this pile of coins, you will see only the bottom coin will move and the top layer or the top tower of those coins, it remains as it is. Most of the times you must have seen it. Why? Because inertia of rest is working here. The coins, they tend to remain at rest. That is the idea of inertia, which comes from Newton's first law. Now, when we talk about inertia can be of three types. If a body is at rest, it tends to remain at rest. For example, this coin, it wants to remain at rest. The pile of coins, it tries to remain at rest. Similarly, if I take a carpet, you do know there is a carpet. On that carpet, there is dust. Now, those dust particles are at rest. The carpet is also at rest. But as soon as I give a push or I put that carpet into motion, you will see that the dust particles, they come out. Why? Because the dust particles, they tend to remain at rest only. And the carpet I'm trying to move and the dust particles eventually settle, they come off. Why? Because of inertia of rest. Similarly, there can be inertia of motion. Meaning, if I am in motion, then suddenly if I brake, my inertia of motion, it pushes me forward. You must have seen that in a bus or a train or anywhere you're traveling. That is why they tell you to wear a seat belt. If you do not wear a seat belt here, what is going to happen? You are in motion, the car is in motion, along with the car, you are also in the motion. But as soon as the car stops, suddenly, the car motion has stopped, but you are trying to resist that motion because there is inertia of motion in you, and you will be thrown out of the car. That's why seat belts are extremely important, right? There is inertia of motion. There can also be inertia of direction. There can be three types of inertias: inertia of rest, inertia of motion, inertia of direction. You must have felt that again whenever you're turning, if you're going through a topsy-turvy road or say hilly road, you must have seen they are like these wavy roads, and at the bends, at the turns, you tend to shift. See, if I'm driving, I'll move along with the direction of the train, basically opposite to the turn that I'm taking, because my body tends to resist the change in direction. And inertia of rest or motion or direction, everything, it depends on the mass of the body. Please remember this. It depends on the mass of the body. So first law of motion, every body, it tries to remain at rest, or it remains at rest, or it remains in uniform motion along a straight line, unless and until it is compelled by an external force, an unbalanced force, to act otherwise. The second law of motion, it talks about the concept of momentum. It basically lays the ground for calculating the amount of force. Force is basically mass into the acceleration. Newton's second law, it defines force to be equal to change in momentum per time, which ultimately leads again to this. The derivation of F is equal to ma, it comes from the second law of motion. And second law of motion is seen almost everywhere. What is the meaning of momentum? Momentum basically means mass into the velocity of a particular body. Momentum is calculated, it depends on mass and the velocity. M into V is basically the momentum. And this particular law, it leads ultimately to the derivation of the concept of force is equal to mass into acceleration. And in our day-to-day lives, everywhere we see this. The second law, rate of change of momentum, is directly proportional to the force, and the direction or the motion, it is in the direction of the force itself. That is what happens, right? You must have seen. Now, a cricketer, if he tries to catch a ball, the ball has certain momentum. Right? The ball has certain momentum, mass into velocity of that ball. Now, if I'm trying to counteract, if I simply hold it like this, the ball is going to get into the hands and pop out. But if I try to catch it like this, there is balancing of that force, and I try to counteract the momentum of that particular ball. Everywhere we use this concept, right? The second law of motion, I would say it can be employed almost everywhere. Here also, when you see a person is pushing this particular box or a cupboard, F is equal to m1 into a, m2 into a, depends on the momentum. F is equal to ma is ultimately derived from that itself. Say for example, any sport, let's talk about long jump. Now in long jump, what happens? A person is going to run for a specified amount of length. That means they are going to run, they are going to increase their velocity. The mass is same, they are going to increase their velocity, and from that particular point they are going to go for a long jump. Similarly, you must have seen, say, if I want to push something, say if I want to push a car, what do? I take a step back, and I try to push it. I try to give momentum, I try to increase my momentum and transfer that momentum so that a body is set into motion. So second law is employed almost everywhere, it is used almost everywhere. It gives you the concept of F is equal to ma, mass into acceleration. It also defines force to be basically this, force to be equal to the change of momentum per time, ultimately leading to the concept of acceleration, right? All right. The third law of motion is my personal favorite. It's very easy. For every action, there is equal and opposite reaction. That means if a force is acting in this direction, there would be an opposite force acting from the other direction. The classic example of this being when you shoot a bullet, when you fire a bullet, you will see if I fire, the bullet is pushed towards this. The bullet is accelerating in this direction. When this accelerate, you will see I have imparted the push to this bullet by using a spring or a coil, and that spring is going to recoil, and that recoil is going to push you in the opposite direction. You must see, that's why whenever soldiers are practicing, or whenever soldiers are aim practicing, they do hold the gun by giving support to the shoulder, that they hold it something like this, because when the bullet is going in the opposite direction, a force is shot here, and if you are not holding that gun properly, you cannot aim properly. For that to be balanced or stabilized, you give your support. There are so many examples of this. As I told you, bullet is one example, meaning the bullet is accelerated, there is a recoil in this direction. Similarly, if there is an action, see, first action is this particular boxer is pushing, this particular boxer is hitting on another boxer's jaw, but the jaw is also exerting a force. That's why you must have seen whenever if you must have seen in movies, etc., that if a person is beating some other person, yes, that person would be injured, but you will also get some amount of injuries on the hand that is beating. Why? Because for every action there is equal and opposite reaction. Similarly, when you are exerting, when you are just getting off a boat, you will see that the feet is putting a force this side, the boat would go this side. The boat exerts some force on the feet, and that's how you can move easily. The basic idea that we use in rocket propulsion, all the space-based applications, they use this idea of for every action there is equal and opposite reaction. Why? Because fuel is burnt and this exhaust or hot gas comes from this side, and if the hot gas comes from this side, the rocket moves up in the opposite direction. So this force of combustion, force of exhaust, is pushing the rocket in the opposite direction. It helps in takeoff. For every action there is equal and opposite reaction. So these are three Newton's laws of motion. Pretty easy. You have studied all these things in your school days. Let me just sum it up, right? Review of Newton's laws. The first law of motion, it basically gives you an explanation of friction as well as the concept of inertia. It states an object remains in rest or in uniform motion unless it is acted by an unbalanced force. The second law basically defines the force. Force is basically equal to ma, mass into acceleration. F is equal to mass into acceleration, or force is equal to change of momentum per time. The third, it gives you action reaction principle. For every action there is equal and opposite reaction. Right? So these are three forces, three laws of motion. Right? That's it. In this particular discussion, we'll meet again in our NCERT series with the next chapter. Please note that we are not focusing on any sort of derivation, any sort of theorem or theoretical stuff. We are trying to understand more and more through examples, through discussion for UPSC civil services preparation. Right? Thank you for watching this video, and if you like this video, you can always follow me on this social media handle @Rahul Sai 22. Thank you again. Jai Hind.